On stage is Diana. She's a developer experience engineer at VictoriaMetrics, and take it away.
Thank you. Can you hear me fine? Perfect. Thank you so much for being here. It's my first time at the SRE Day Amsterdam. So yeah, let's kick it off. Today I'm going to be presenting cutting through metrics cardinality noise with VictoriaMetrics. So a bit about myself. I'm an SRE that I worked in observability, and 2 years ago actually is the fault of the SRE Day organizers. When I was at London 2 years ago, I participated with my first talk and I really liked it. So since then I got the conference bug and I started going at conferences explaining different technical topics to the audience. So 2 years later, right now I'm doing this as a full-time job. So a bit about also, besides being a developer experience engineer, I'm an OpenTelemetry contributor, and I'm one of the organizers of Cloud Native Days Romania. We have their conference in May 2026, so would be very happy for you to apply as well with that topic. What's on the agenda for today? We're gonna see high cardinality, what's all about, what are the root causes and how to fix high cardinality. Then we're gonna deep dive into VictoriaMetrics architecture. We're gonna see a demo about Cardinality Explorer, that's a feature from VictoriaMetrics. And then I'm gonna show you some tips as well in dashboards using Grafana, how you can better investigate and determine high cardinality, and obviously wrap it up. So as an SRE, and I'm sure like every one of you has managed the cryings in the middle of the night about latency, and not only in the middle of the night, but the idea of latency causes like a real problem in observability. So yeah, lagging is a big issue. It drives slow monitoring. It really is a pain in one's butt. So the idea is that I think like maybe the culprit, one of the big culprits of latency and slow monitoring could be cardinality. Cardinality is the number of unique time series. So obviously, high cardinality, you're going to have a high number of unique time series. Low cardinality, a low number of unique time series. So what's the problem? So why do many companies and engineers complain about high cardinality? Well, it will drive up like the resource consumption in storage, memory, and CPU. Then we're going to have slow query performance, system stability risks. Obviously, will create an increased cost overall, and will affect us in getting valuable insights from the monitoring systems. So overall, we want to get rid of high cardinality, right? If we backtrack a bit in the realm of monitoring, because VictoriaMetrics I cannot explain the whole architecture on VictoriaMetrics without explaining Prometheus first a bit. So when Prometheus appeared, that was really great. It's such a great project and a great tool, monitoring tool that we are still using nowadays and is really efficient. And it's focused on metrics, right? Only on the signals of metrics. Obviously, in the whole realm of observability, we have logs, traces, profiling, and also events. But Prometheus focuses on metrics, right? It uses a pool-based model. It takes the data and it stores it into its own time series database. It's using the scrape manager, the rule manager. It has the web UI, obviously, API, alert manager, and a node exporter. So if we are familiar with this architecture, we know how to use and we know how to scrape using the scrape jobs with Prometheus. Prometheus uses Prometheus-QL as a query language and focuses on the four main metric types, the ones that we are using in our other systems as well, but counters, gauges, histograms, and summaries. And why do we say that metric can have more than one time series? We will have one metric, but this will expand according to the numbers of instances or servers that we'll be using, right? So one metric, for example, will have as many time series as instances that we will be using, right? So imagine like when we are trying to create our metrics and we are using a lot of labels. Sometimes we don't really know why are we using those metrics in the first place. The chaos will soon, start happening, and we're gonna see high cardinality. Many of those issues focus on labels with unique IDs, labels that drive huge cardinality and will cause this basically slowness, this latency in our systems. So let's get into dive into a bit further here. So the root causes of high cardinality, they refer, like we said, labels with a large number of unique values, user ID, session ID, instance ID, etc. Overscraping or overexporting techniques, or exporters that will tag too much, like unique IPs, device IDs, and so on. So what about overscraping? Overscraping is, for example, when you define a scrape job and you use a scrape interval that is lower than the interval of time for when your metrics will change. So normally, let's say you have a 30 seconds, 60 seconds, depending interval of time when your metrics change, and in your scrape job you define a lower scrape interval. So what you're gonna have is you're gonna create your overscrape, and basically you're gonna ingest and you're gonna overcollect, and this will drive the increased CPU also and network usage, right? So let's not do that. That's not a very good idea to overscrape, and you should always put the both in sync. Overexporting is another idea that's also you need to think about it and do it properly. Don't do it, basically. Overexporting, which means that you're going to use those labels with unique values that will drive the high cardinality. And the recommendation, I would say that better not to use some of the metrics than to use not to use in the sense that you need to go and clean up your metrics, because you're not going to use 100% of your total, right? So you need to think very, very carefully at what metrics are you using in reality. And the overtagging will be when all the node exporter collectors will be enabled, and each metric will get multiplied, right? With some ideas will be like device ID. Right, so these are like some of the potential culprits of high cardinality, but what should we do in this case? How can we do it better, right? So once we already touched on this, use the scrape strategies, use the same interval of time for when your metrics change with the scrape interval in your Prometheus job, and drop any unneeded labels. So in case you do have those labels that will drive high cardinality, you can just use the label drop, and that will be also something really, really good for you. You can use pre-aggregated views. So that means you can aggregate early and export less. In VictoriaMetrics is something that is called a concept that is called stream aggregation. Is somehow similar to the recording rules in Prometheus, but actually how can I say, the ingestion happens before, and basically you don't need to use as many, you don't need to ingest as much data as afterwards. And so you can summarize with histograms and not IDs. That basically will make your queries a lot more efficient. You can also use instance grouping. So instead of having job names and different instant unique IDs, you can just group them and also have job deduplication. But better works to cut the noise at the source. So the same, like I said, 50% of the metrics that we are implementing will never be used. So it's a good idea to go over and analyze a bit the metrics and get rid of really the stuff that is not necessary. So we're coming to VictoriaMetrics. Like I said before, if you're not familiar with VictoriaMetrics actually appeared as an idea from some engineers that wanted to address the issues of efficiency and scalability, well, not efficiency, but scalability with Prometheus. So they created this open source project. It's still open source. And it uses, at the moment, 3 signals. So VictoriaMetrics, which is the classic signal, and Victoria Logs that was released in production last year, and Victoria Traces that is under development, but it's already, you can already work with it, so that's not a problem. It's not yet in production, but it already has been released in June this year. Obviously it has some parts that are enterprise, but I'm not going to get into that right now. And the interesting part is that I wanted to discuss here is the data ingestion architecture. So how does VictoriaMetrics works under the hood? So basically, if you think about the same idea for Prometheus, with the scrape jobs and the exporters and everything, VictoriaMetrics will use a component that is called VictoriaMetrics agent, VM agent in short, that is a lightweight collector. And it's nice because it's passively receive metrics from application that will be pushed with other protocols, like you can use Graphite, InfluxDB, Datadog, whatever. There are loads and loads of protocols that are compatible. And also VM agent collects the metrics, process them by filtering unwanted data, will change the labels as well, will combine multiple metrics together, and will forward the processed data to one or more storage systems using the remote write protocol. And then the data will be sent to the VM insert nodes. So this part is where will be the ingestion layer, so will be ingested, will receive the incoming data and will compress it into smaller packets. And that will be sending it to VM storage. VM storage will handle the long-term storage. And us as users basically will be using either PromQL or MetricsQL as a query language to operate and work with the queries and get the information from the query engine with the help of VM select. So that's the component there that does basically the query engine. Right, and obviously we will use that in a user interface called VMUI, VictoriaMetrics UI. And this is what I want to show you next. So let me just do this. So you already see that. Allow, I'm guessing, okay. Right, so I'm going to get closer because I don't see this. Right, so this is, you see it, right? Yeah. So this is the VM UI, so the VictoriaMetrics user interface. Basically, if you have instances for VictoriaMetrics, you'll see here all the information. The cardinality explorer will be shown here in Explore Cardinality. So what happens is that you're having all your metrics here with information in this panel, and it will be easier for you to troubleshoot. So if you go to metrics names with the highest number of series, the most expensive metric will come at the top. So it'll be here. And we'll show you, the number of series, the last request when this was done, and you could also measure out, by going in the past and seeing how this evolved. So you'll be seeing like, okay, how does it compare with 1 day before, with 1 week, and so forth. And we'll give you an idea about this analysis. So let's say I want to understand a bit more about this expensive metric. I'll click into it and I'll see the information about the label with the highest number of unique values. So what does it mean? It means basically that this label name here, the resource, will multiply 143 times my metric, right? So I'll multiply this metric right here by this number. So in case, obviously, I have a big number or some number that bothers me, I can always go back into my scrape job and I can say, okay, maybe I will think about the logic here. Maybe I want to drop this label. Maybe I don't need it, and you could also compare it with your own dashboards. So that's something really useful and unique for VictoriaMetrics and not unique for Prometheus because it doesn't have this. And it's good for troubleshooting in general. So going back, you can also scroll down here and look at labels with the highest number of unique values. So you could also look down, it gives you a different overview. And here you can check, okay, maybe I want to see this bundle zip, what does it do? How much time is it correlated with this metric name? And obviously this works, how can I say, this panel works as an insight, giving you insights for your troubleshooting. Obviously, you need to correlate it with your own dashboards. So, for example, here I have something open that's from VictoriaMetrics. By the way, you can access both of these like instantly. There are playgrounds, and you could correlate it and help yourself and play around a bit and see how it's done. But yeah, basically you could go to your own dashboards and understand, okay, do I really need to use that specific label, that specific metric? Do I need to use the label drop? And you could go ahead and troubleshoot it. Another cool stuff that I wanted to show you, because it's linked with Explore Cardinality, you can use top queries. So the top queries here is like the queries with the most summary time to execute. So it'll be the, let's say the query that is most expensive and also the one that lags a lot, right? And let's say like the duration here probably would be a lot higher, and I want to understand why. I want to understand when did this happen. Okay, then I could go and execute the query. Obviously, I could go ahead and change my interval of time when this happened and understand, okay, okay, look, so it happened at this point of time and then it started to grow. So maybe, I have an issue here. Another cool thing that you can do here, you can actually trace the query. So you can enable this part here and go and execute the query. And that will give you like a nice sort of Jaegerish overview, and it will be good for troubleshooting. So in case that you do want to find out, okay, what happened here in this query, what's wrong, how I can troubleshoot it, then you can also have this available. There are other cool tools here that I'm not going to go in here in depth because it will take me too long, but I do definitely recommend you to, okay, the click is not working. Anyway, I do recommend you to click over them. Yeah, okay, so Trace Analyzer is basically what I've been doing right now. You can just upload the file yeah, you can see the trace and the same view that will be in a way, super Jaegerish. I'm not sure why I'm using this, but I think for me it looks very Jaeger-like. And yeah, you could. They also come with some default dashboards, and a new feature here released is called alerting rules. That you can use it also. That will be very interesting for you. Okay, so this was the part that I wanted to show you that you can do, and it's totally unique in VictoriaMetrics. You're not going to see it in Prometheus. Let me go back to my screen. Yes. Okay, so to sum it up, Cardinality Explorer is helping you basically get all these insights that you need. It's something different from Prometheus. It's a way, let's say, forward into the way that it enables engineers to go understand a bit high cardinality. What are the labels? What is high cardinality? How this drives, all this correlation between the labels and the unique values. and it's something nice to have. So for me, I also wanted to give you some tips to spot high cardinality in Grafana. So when you use that with your VictoriaMetrics clusters, you could look at the particular components in the architecture I've shown you previously, because everything is correlated. So at some point you'll see, for example, VM storage that will have peaks in either CPU or memory, and that's a direct correlation with the idea that some high cardinality will happen there. So all the components basically in that architecture will be touched once you're gonna get high cardinality. So you could take a look, okay, in my dashboard is high cardinality, is high memory here present for VM storage, what happened here? And you could correlate it also with Cardinality Explorer. The same for CPU usage for VM storage. For VM select, because it's handling the query processing, and once you're gonna see spikes here, is gonna be very interesting for you to debug and think about, okay, should I use aggregating? Should I use the stream aggregation? Maybe it's a good idea to do that before the query actually blows up. And also VM insert will be handling, like I said, the insertion part, so the insert layer, the ingestion layer, and this will also be affected by high cardinality, and it's good to look at the spikes here for CPU, memory, and so on. One particular query that is unique in MetricsQL, so MetricsQL is the query language of VictoriaMetrics, is to look at VM new time series created total. That basically gives you the number of unique time series, brand new unique time series that were created. So if you're gonna get spikes here, then you're gonna see also that is a problem of high cardinality. And every jump basically will mean a new unique label combination that is flowing in. Also, you could use it in a dashboard, so you could do the sum. Well, for me, it's super small, but I'm not sure if you can see it. I need my glasses. Yeah, so it's sum rates VM new time series created total, and for example, this was in correlation with some increase VM new time series created total. Anyway, so basically this will prove, this will show you the churn rates of the time series database. So basically, when the time series were created and then dropped and then removed. So if you're going to have a high rate, then you're automatically going to have some high cardinality, high churn rate as well. So to sum it up, just think about the ideas that you could do a lot of things to optimize, right? To optimize and think about how you are dealing with metrics, how you are working with metrics that I showed you before. I had another talk that I went into depth about how to optimize Prometheus. Prometheus is a very, very cool tool and very cool project. You could do a lot of things, like scaling horizontally. You could add more instances. You could use recording rules. There are lots of things you can use, and you could explore that part. But in case you want to, you are ingesting a lot of metrics, so you're like literally working with millions of metrics. At some point, Prometheus won't scale, right? So it won't be able to deal with that sort of workload, with that ingestion rate, right? And then you could use, obviously, VictoriaMetrics with the explanation and with the information that you've seen. And also use Cardinality Explorer, is very good for troubleshooting. Do give a shot using the MetricsQL, so the metrics query language. And yeah, the world is your oyster. You could play around in VictoriaMetrics Playground, in Playground Grafana. By the way, these slides are available on my GitHub. I will show you later, so you don't need to photograph. You can download them. We have like also Prometheus benchmarks that you can do your own benchmarks, you can analyze them. We also have benchmarks with Mimir and other tools for Victoria logs and other comparison and documentation. We also released a fork of OpenTelemetry demo, and yes, VictoriaMetrics is compatible with OpenTelemetry, where in this fork you can play around with the OpenTelemetry demo and find out how the 3 signals from VictoriaMetrics are playing around. Offered by Grafana, you have all these nice, cool dashboards, and you can find out all about VictoriaMetrics ecosystem. I'll leave you with some resources here if you want to scan for particular solutions. And also VictoriaMetrics community, we are available on Slack. Anytime you have like a query, an issue, any question, we are more than happy to help you. If you have any questions, just let me know. Thank you very much.
Does someone have a question?
You said like one of the tips to, if we cannot remove labels, they can be pre-aggregated. Can you elaborate a bit? How can that be done? It's not the same like using histogram and buckets to group them, right? It's different.
Yeah, exactly. Because it's a specific thing for VictoriaMetrics called stream aggregation. That's used, so it's something different, it's not the same thing. I would suggest you to, I will give you the documentation to read, because it's like a whole concept about it, how you can implement it. That will take me another talk to explain it. Actually, one of the founders that they worked on this, they have a different talk explaining all the concepts and everything. It's something different. So it's, let's say, like conceptually maybe close to recording rules from Prometheus, but the whole ingestion part happens before. So basically, everything happens in real time, and you don't have to store that and then do all the processing afterwards. So it's a bit different, in that term. Sure.
Thank you so much for the talk, very insightful. I wanted to check whether there is any kind of telemetry etiquette you recommend, especially with using the cardinality explorer, or is it just, send everything and then we can observe characteristics of everything that's coming in just from the word go?
Exactly. So you can use whatever metrics you want. I mean, in case telemetry here is probably not the best word to use it in this context with high cardinality and cardinality explorer. It's this tool, like Cardinality Explorer, will show you, for example, depending how are you doing it, which metrics are the most expensive, or queries take more time. But it's really up to your use case. For this particular part, I don't have any specific recommendations. We can talk about it and to understand a bit more like the use case. That would be nice. Thank you.
Yes, thank you very much, Diana.